Greetings, class. Welcome to lab number 3, ELEC1631, Power Quality. In this lab, we're going to look at another switching circuit. This is straight out of Wildy Chapter 30, and we'll be going into this circuit in some detail in our lectures. So what we have here is a switcher you're all very familiar with. It's a TRIAC. We're actually going to use a dimmer switch to adjust the current to a 57 ohm load. Okay, so very simple. We're going to apply 120 volts AC and use our fluke meter to monitor the current using our line to neutral voltage as our reference voltage. Okay, so theoretically then, when we adjust the dimmer so that the current is full on, that corresponds to an angle of 0 degrees on the AC waveform, we should get 2.1 amps, 120 volts divided by 57 ohms. In fact, when we do turn that dimmer full on, we get about 1.95 amps. Very close. This is probably not exactly 57 ohms, and this probably won't be exactly 120 volts AC. Okay, so in part A, we're going to actually intentionally distort the current. So, excuse me. So what we're going to do is adjust this angle so that instead of full on 1.95 amps, I'm going to create some distortion. So I'm going to adjust the angle, and we'll see from our fluke that we can actually see the waveform. It'll correspond to something slightly less than 90 degrees. That corresponds to a current, a total effective RMS current, which includes the fundamental and all the harmonics that we're generating. And that total effective current is 1.5 amps RMS. We'll further see that the triplen, the third harmonic at 180 degrees, is 39% of the total effective current when we take into account the geometric sum of all the harmonics plus the fundamental. And the fluke also tells us that based on the fundamental current, the total harmonic distortion is about 53%. Okay, so that's a fairly distorted waveform, and you'll see that when we look at the waveform on the fluke. It looks a little bit like a chopped triangular waveform. Okay, then what we're going to do is drop the current to a half of the original distorted current in part A to 0.75 amps. And that angle you'll see in the waveform is something slightly less than 135 degrees. So that corresponds to, according to the fluke, the current probe, the distortion in, or the contribution of the third harmonic, or triplen, increases to 55% of the total current, the total effective current. And the total harmonic distortion on the current more than doubles. So we'll see a severe distortion in the current when we actually half the actual effective current. And the reason for that is because as we keep adjusting this angle, we are essentially increasing the contribution of all the harmonics to the reduced current. So in effect, the current becomes more and more distorted as we approach an angle of 180 degrees. Okay, let's now review the setup for lab number 3. So here we have again our AC power supply, our TRIAC or switcher, and our 57 ohm load, and our fluke meter. That's going to be analyzing the harmonic content on the line side of this circuit. Okay, so let's turn on the power. We'll apply 120 volts AC. And at this moment, we should see very little current because the TRIAC is turned off. So let's verify the current for an angle of 0 degrees. And we get approximately 1.98 amps, okay, total effective current. Now, if we look at the current waveform, you'll be able to see that it's actually fairly sinusoidal. It's actually quite a nice sinusoid, which is what we expected because effectively there's no switching going on here. Okay, so now what we're going to do is drop the effective current to 1.5 amps by adjusting the angle on the TRIAC. And there we go. So the waveform you can see is severely distorted. And now let's have a look at the harmonic content. So we'll toggle to the histogram. And you can see here that if we just adjust over to look at the percentage contribution of the third harmonic, the 180 degree harmonic, we'll see that it's about 40%, 41%, close to what we had surmised earlier. Okay, and to gauge the total harmonic distortion, we go back to data, toggle to data on here. And if we just toggle over, we'll see that the percentage total harmonic distortion based on the fundamental for the current is about 53%, which again, similar to what we discussed earlier. Okay, now what I'm going to do is drop the current, or more severely distort the current, to 0.75 amps, half of what it is right now. And there we go. Now let's have a look at the waveform first of all, and it's clipped even more than it was before, which results effectively in more distortion to the current. And now you can see that the harmonics on a percentage basis have actually increased at the expense of the fundamental. So if we toggle over then, you'll see now that the third harmonic is about 40% or so of the total current. In fact, all the harmonics are contributing more at the expense of the fundamental, which is another way of saying there's more distortion in the current waveform. So let's now toggle over and have a look at the data for the total harmonic distortion of the current based on the fundamental. And it jumps to about 104%, which is quite substantial. This is telling us that, in fact, there's more distortion contributed by the harmonics than there is to the fundamental. So the lesson here is that with the switcher, as you start to reduce the load, you actually create more and more distortion to the current waveform. And if there are enough switchers in your plant, you could actually create a considerable amount of distortion back on the line side of the utility, which is not a good thing, because that's not being a good corporate citizen. You're going to affect all the other customers on that point of common connection at the substation. Now, just for fun, let's just have a look at the harmonic distortion on the voltage. And we see it's only about 2.1%. We can live with that, but again, keep in mind that this is a very tiny load that we're drawing off a rather big supply. If, on the other hand, the supply was not an infinite bus and the load was substantial, then the distortion on the voltage would be considerably greater, to the point where it would probably exceed 3%.